This is Chef Push in 2015. I changed the title a little bit because it seemed like it fit the content a little better. So my name is Mark Anderson. I'm an engineer and chef. I work on the community team right now. So I work on Push, but I also am working on just trying to build the open source community around Chef Server 12 and all the new things we newly released. As I say, I've been mostly a server engineer the past few years, so that's probably the context you'll be seeing me in. So I'll start out with, I imagine all of you have at least heard of Push since you're in the room. How many of you have dug into Push at all? Used it? Okay. So, all right. So it's worthwhile for me just covering a little bit about why we did Chef Push, what it is right now. So why did we do this? So Knife SSH has some problems. Key distribution is a pain. You end up putting an SSH key on every node. Sometimes you have the anti-pattern of having an SSH key for every user, so every admin, there's all sorts of anti-patterns you can slip into with key distribution. It's difficult to audit. You have a shell or something equivalent. You're not really sure what happened. Extra work is required if the node is behind a firewall. Yes, you can build a bounce box, but after a certain amount of time, that gets old. And it really doesn't scale much past tens of nodes. At least I can't decipher much of what's happening. If I run Knife SSH on 30 or 40 nodes, it becomes nearly incomprehensible on what actually happened in the end. And we started...
Turn up the volume.
Sure. Let's see. Cool. I guess my guy in the back fixed it for us. Is that better?
Yeah.
Cool. Thanks. I have a quiet voice, so sometimes I don't carry to the back of the room. So if I stop carrying, you can do semaphore jumping jacks in the back, and I will try to catch that. So we looked at alternative systems, and none of them really fit our use case well. And so we kind of decided on a few features we wanted. We wanted a remote execution system that is robust under network and client failure. Once you get above tens of nodes, you pretty much have to expect you're going to have dead nodes in the job. I mean, just scaling involves failure. We wanted to gate the execution of a quorum being available. Sometimes you want to start a job, and you don't want to start it unless all the nodes are available to run, or most of them. Sometimes you don't care. You just want to do a best effort work. But sometimes it's important to get all or nothing. And so we built a quorum feature into this. We wanted presence information. We wanted to know if the node was actually available to execute jobs. We wanted this to scale to hundreds, if not thousands of nodes. We wanted it integrated in the Chef authentication and authorization systems. We've already done key distribution work to get Chef client on the machine. We want to kind of reuse that because key distribution is hard enough as it is without having to do it twice. And we wanted something that was going to work behind firewalls and NATs and other complicated structures. Quite frequently, your dev box doesn't have a straight path to the node under management. And one of my constant fun at Chef is to discover just how naive I am about how complicated customer networks really get. Last 2 years have been quite an amazing trip as far as discovering just how complicated real networking systems get and how much fun it can be to get Chef running in those. So, the one-line summary of what push jobs is, and just in a nutshell here. This is a command line that runs Chef client on a bunch of nodes, has a quorum of 90%, which means 90% of the nodes have to report in as available before we start it. So this has a search built into it, finds all the nodes with a role web app, submits a job to the Push server with that set, checks quorum. If 90% are available, we start executing the job, and then gathers success and failure of the job and reports this all back. And this is supposed to scale to tens of nodes or thousands. So just a pictorial version of this lifecycle. The top is the server, the bottom is the client. So we send a REST request into the server with the job. It's accepted. The server sends commands to all the nodes. The nodes decide if they can accept it. They acknowledge that, we get quorum, we start execution, clients execute, we collect results. It's a very simple workflow, but one of the guiding principles of this whole design was as simple as humanly possible. The design principle, as simple as possible, but no simpler, is we really tried hard to do that. And sometimes there's some gaps in features that we figured out there's ways you could build it, given the primitives we gave. But so we deferred building a more rich feature set just to make sure you had all the basic primitives in place. So the Chef there's a server and a client. The server, Erlang service. We love Erlang. It's been great here at Chef. This extends the Chef REST API with endpoints for job creation, tracking, listing, output results, things like that. And one extra special endpoint, which is the client configuration endpoint. The rest of the control happens over ZeroMQ. So it's a separate path, not using the HTTP REST API. So we send heartbeats, get heartbeats back from the nodes, and then execute commands all over ZeroMQ. And all the ZeroMQ packets, and this is version 1.0, all the ZeroMQ packets are signed, but they're not encrypted. Again, it was a simplicity decision. It's a whole lot easier to debug early stages of protocol when you don't have to reverse engineer the encryption. The client is incredibly simple. It's about, 1,000 lines of Ruby. And a good hunk of that is options parsing. So it just receives heartbeats from the server, sends heartbeats to the server, and executes commands and returns results. It's essentially a small state machine. And the server essentially tracks the state machine execution. If it gets out of whack, basically hammers it back into the proper state. Most of the complexity, the client complexity is pretty low. We did that in part because we wanted to be able to re-implement the client easily. So most of the configuration is done by this config endpoint API. And the client initiates every connection to the server. The server there's no open ports on the client. The client calls the server for everything. And initiates the listening to the server heartbeats, and initiates the connection to the server for commands and stuff like that. So again, just a picture. Just to illustrate this, the server is on the right, client's on the left, makes HTTP connections, and then ZeroMQ pub sub to get heartbeats from the server side, and then uses a ZeroMQ dealer router type pattern to send heartbeats to the server and get commands back. And just a point, just to remember, most of this stuff is all going through what we call the message switch. And I'll be talking about that later, so I just wanted to call that out so people saw that. The other part of this is the Chef Push knife extension. This provides access to the REST API, just like the REST knife provides access to the rest of the Chef REST API. Again, relatively simple. You get node status, job control, start, stop, finish, state of jobs, all that sort of stuff. And the final part of this system as 1.0 is we had some access control. Again, simplest possible thing we come up with, which was a push jobs writer control group, governs who can create a push job, and then the readers group lets you look at the state of push jobs and what push jobs exist. Again, this is going to be improved in future versions, but this is kind of the simplest thing we could implement. And there's some historical choices around, this was done around Chef Server 11, and all the functionality we needed wasn't yet available to do anything cleverer. That's changed, and so will we. The other part of access control is there's a wait list of commands you can execute. So you could restrict the push clients to only run Chef client, or you could have a broader list, and that's is a config value for the client. So the workflow that we see people using is it is always Chef client in your whitelist. And if you need another command, you can run Chef client to update the push jobs whitelist config file and get more commands in, or take them away. Again, trying to keep things simple, comprehensible. We'll expand on that in future versions, but that's where things are now. So this is 1.0. If you downloaded this from the website today, this is what you would get. That version scales to about 2K nodes, heart beating every 15 seconds. Works against Chef 12. And this has been open source since fall 2014. It was actually open sourced the same day we open sourced Chef Server 12, but it kind of got lost in all the announcements of Chef Server 12. In parallel, we've been working on new features since last spring. But again, the fun of Chef Server 12, we were pretty much focused on getting Server 12 out and stable. And so these features kind of got deferred. And I've been able to now pick these up and start getting these out the door. The other thing is that we really wanted to open source push years ago. But we realized we built it against private chef, enterprise chef features. And it was pretty meaningless to open source it until there was an open source chef server that could support it. I mean, it's kind of cruel to give you this toy and say, oh, but you have to pay money for this free toy. So we held off open sourcing it until we had what I feel is a good story rather than kind of a jerky story. So, you know, there's a few limitations here. As I say, there's a scaling limits. There's we haven't quite kept up with all the features of the latest Chef server. If you use multi-key against push 1.0, it doesn't quite work because we haven't taught all the federated pieces of the Chef system to understand that there are two keys you could auth against, or more than two keys sometimes. And so if you use the multi-key feature that just rolled out in Chef 12.5, I think, I can't remember the number, then push doesn't work. We'll fix that very soon, but this is what you get today, as if you downloaded it right now. But coming very soon, we're going to get Chef Push 2.0. They're just not quite ready yet. They're finishing baking. I've been working on scalability and stability testing and just trying to get this thing to be really, really solid. So just going to talk through what's going to come out in 2.0. First thing, end-to-end encryption. That was the thing we really wanted to do first time around, but you know, we knew we had to have, but we deferred. So it's a breaking change to the protocol. There have been how many attacks that basically downgrades crypto protocols? We didn't want to be on that list, so it was simpler to just be always encrypted all the time. Of course, that breaks the protocol, but the trade, I think, is worth it in terms of a very simple, secure audit model. Also, the encryption library we used, CurveCP, is philosophically very much about encrypting all the time as the only choice. There are a lot of features we wanted to build that we simply couldn't build until we had encryption. Smarter command line arguments. Obviously, the stuff that goes on a command line is actually often sensitive, and then output return. If you dump your password file, you really don't want that going over the network. So again, this was a gating factor for a lot of the new features we wanted to add. So as I say, this is built on we upgraded to 0MQ4 and picked up the CurveCP encryption protocol. In general, we try to keep to not implementing our own crypto protocols because that's crazy. So CurveCP is pretty modern, safe protocol. There's a lot of design effort done by it to resist the modern series of attacks, which tend to be timing and CPU and other caching attacks. And so, again, seems to be a well-engineered, well-designed system, and it provides forward secrecy for all connections. So once we drop this connection and redo it, a third-party listener can't pick it up and capture that. We're still using the client key for the bootstrapping the auth. But once we bootstrap, we're moving to elliptic curve keys, and the actual communication is all done using the CurveCP set of protocols. So that enabled the next feature, which is command environment and config files. So now you can send along to the push job a config file up to 100K. And we had an internal application for push jobs where you had a command, but there's a big config blob that went with it, and it was bigger than the command line would accept. So having a actual config file sent over the wire worked out to be really useful for them, and I hope it's more generally useful. Also able to set the effective user ID, the working directory, and other general environment variables. And again, I feel like this makes the whole command system a little more useful for people and flexible. Next one. Everybody, as soon as we release push, everybody's like, how do I get the output back from my command? Because right now, push 1.0 only captures success or failure, but doesn't actually capture the command output. So in 2.0, we now have command output capture. It's all or nothing. You capture all the output for all the nodes in the job or none of it. And basically return it to the server, and you can fetch the individual execution output from the server. No streaming output yet. That's something we want to add the next rev. There are internal users that have a bunch of ideas about streaming protocols and how to do it. You can imagine, I shouldn't name customers, internal projects that we haven't announced, but we are working with other teams to try to produce a general streaming protocol to get output back to a Chef server. And so we're going to pick up on that. The other thing is we're finding people building tools on top of push. And in general, even just the command line interface is a little, you submit the job, you wait a bit, you get an answer. But you don't get much intermediate state. And so we've added server-side event feeds that give you real-time updates on the progress of the jobs in the system and your individual job. So there's two feeds. One is a per org feed, which basically lists the jobs that have been running for the org. And so it just is it's a summary roll-up, gives you start, stop, result of the job. The other feed is a per job feed, and that gives you, as nodes report in with various state changes, it gives you updates, and so you can track the actual execution of your job as it flows through. Imagine GUI interfaces would be really easy to build with this side of thing. The other thing that's, I call it a feature because it's really useful, but it's a little different than the rest of the features in that it doesn't provide new functionality, is it's now stable at 10K nodes. Been doing a lot of stability and just general performance drive. And so we're pretty comfortable at 10K nodes now. That's 10-second heartbeats, which is a little faster heart beating than we previously demonstrated. And this is on a C3 2XL, which I think is a reasonable, that's not crazy hardware. We're not putting our thumbs on the scale with this.
Does the number go up as you increase your server architecture?
Not yet, and I can get into that in a bit. But and so we consume about 2 cores right now, and we don't really use more cores. And a faster single core would make it go faster, but there's not that much headroom on a single core these days. So, and then about 1K nodes in a single job. And more than that, you start getting into some stampede problems that you have to be careful of. And I'm not sure right now it's useful to run more than 1K nodes in a single job, just because if you run a 1K Chef client runs all at the same instance, unless you've been seriously provisioning your server, you're going to be unhappy. And we're not done scaling. There are a few tweaks left in the short term, and then there's some bigger architectural changes to take to keep on scaling. So I'm going to try to do a demo, and apologize for this. This is I was going to do a video, but I could not get the video to stream over the network, so we are going to do ASCII Cinema. So, and I was too chicken to try to do a live demo on stage. So what we have here is that C3 2XL. This is a standalone Chef server. I'm just going to, I think, can you guys read that type? No? Crap. Sorry. Yeah, this is HTOP. Let's see. Nope.
That was a little better.
Yeah, just a second. Unfortunately, there is a 142 by 50. Sorry, this is the last-minute fallback when you discover that you run your demo on the conference network and it doesn't work. Oh, just bear with me one moment. Well, this happens to my non-live demo. I guess I feel better about. well, I may have to run with this and do interpretive dance to convey the true meaning here. Oops. 142 wide. All right. Unfortunately, the ASCII cinema is dependent on exact proportions of the screen to work. And I know. All right. And I will just, oops.
Everybody shut their laptops. Let's try live.
All right, let's run this. All right. So I'll show my HTOP session here in a moment as you wait for my slow typing. The other reason I don't do a live demo is that my ability to type is inversely proportional to the number of people watching me. So we have a chef server here. And so none of you can read this, but pushjobs is eating about 200% of the CPU. My other demo was, this is a, it typically is more typically about 100%, but I just deleted my demo file here a moment ago, so this is the not so good demo. So anyways, so we have here a chef server. I'll point out that pushjobs is eating, as I say, about 100 to 100% of the CPU. It's pretty stable. We have 10,000 nodes heartbeating against this 10-second heartbeat rate. And that's a real cluster. I set up a 20 nodes in EC2, each one running 500 Docker containers, each one having with push client and chef client actually running in it for real. This is not a simulated thing. And so, so do a quick list of the nodes. And so, yeah, there are 10,000 nodes, which none of you can see. So I'll just skip through this pretty quick because I don't think it's much value at this point. But start a push job here and run the first 1,000 nodes off the list. And start that. And start it. We see the job start. We're voting. CPU bumps up to about 200, 300%. This is the stampede problem I was trying to illustrate. Run the nodes, and we finish in about 19, 20 seconds. And what I ran there was sleep, a 5-second sleep on 1,000 nodes all at once, because I don't want to run chef client, because 1,000 chef client runs all at once is going to be a disaster for this particular server. And just running it again just to show that it works twice in a row. This is actually really nicely stable, which is a big step up from where we used to be. So I'll be glad to show demos later to people who are actually curious. But anyhow, back to the main line of presentation. It's not a real talk if something doesn't go wrong. So as I say, this was done with real push clients. We have provisioning scripts that, with Chef, of course, that provision up 20 node clusters, set up 500 Docker containers in each one, and run it through the testing. We also do a lot of testing on the simulator. Been having a lot of fun understanding limits of the current system, and if you haven't played with SystemTap, it's amazing. The new Erlang now has instrumentation that lets you track things through from an Erlang code into the C libraries and on into the kernel. And being able to get a vertical slice of what's really going wrong with your system has been super helpful for this. So someone asked a question earlier about kind of the number of clients and all that. And so there are a couple axes of scaling that we've been testing. Number of clients, the heartbeat rate for a client, and the number of clients in a single job. And below 10K clients, there's pretty much a linear trade-off on heartbeating rate and the number of active clients. Above 12 or 15K with push right now, we start hitting some other limits on management of basically the timeouts for dead non-heartbeating processes start getting to be a performance bottleneck. We're working to fix that soon. But right now, even if you slowed the heartbeat rate down, we wouldn't be really very stable much past 15K. That should be fixed. I don't know if it's going to go out in the very next release or if it's going to have to wait for the next minor. But as I say, right now, we're good at 1,000 nodes and 1K jobs. And stampedes and job execution just have to use some care. A little bit about what we've learned from the scaling. And this sort of leads into where we're headed in the future. So when we designed this, we used ZeroMQ. ZeroMQ is really, really awesome. It's great to get started with. We had a working prototype of end-to-end communication in only a few days with ZeroMQ, which was just kind of knocked our socks off. The problem is that we're hitting some of the limits of ZeroMQ. And these aren't even necessarily ZeroMQ problems per se, but ZeroMQ works really hard to provide you with a way of managing thousands of net connections in a language that doesn't need to do threads well. So if you're, a lot of traditional scripting languages, hundreds of threads is not really a good idea. They're not very friendly to that. And ZeroMQ provides a really nice interface for that. Erlang, that demo I gave, the Erlang service was running about 12,000 threads. It just doesn't care. And so a lot of what you get from ZeroMQ doesn't help us. And one of the things ZeroMQ does is it binds one TCP port to one logical port, which can only be owned by one thread. And so when we're hitting CPU limits because all the communication is going through this one thread. And we don't get much scaling because of that bottleneck. Because the client heartbeats and all the command messages go through this single socket switch. And as I say, it ended up being a bottleneck around 2K messages a second. So these 10,000 connected clients with 10-second heartbeats was 1,000 messages a second for heartbeating, and then the messages for the job execution, running the 1K node job. You can kind of see how that works out to be that 2K limit. And that's just kind of a heuristic, but that's kind of the limits we're seeing right now. Did an experiment with multiple command switches to get past that bottleneck. It turned out to be a bit more complicated than I thought it was going to be, and the initial performance win wasn't huge because basically we're hitting the library, the binding library implementation. So ended up not being as much of a win as I thought, and I ended up adding a lot of mutexes just to make the library work right. And so didn't get the performance I wanted. So 2.0 is nearly feature complete. And this is basically my punch list for when I ship it. And when this list is done, I think we're ready to go. And I'll be shipping RCs a little bit before this, but this is kind of the countdown to 2.0. So I'm expecting this very soon. So I need to get some knife extensions for the new features. Some of that's just tweaking command lines. There's a bit of work around the server sent event stuff so that the knife, right now there's not much use of server sent events anywhere in knife, so I have to add some stuff to get that so we get a nice real-time reporting out of the knife command line. Documentation of all those features. What you saw there is basically the documentation that exists for the features right now, so I have to write up something better than that. Other thing, Windows testing and stability. Chef has been really working very hard to make Windows a first-class citizen for everything. And right now, the push client needs a little bit more testing and stability. We make some of the classic mistakes about where you put the config file, and there's just a lot of little tweaks and dings about, don't assume C: is where everybody puts their config file. And just a bunch of stuff around that to clean up and just make nice. CentOS 7, that is in flight. We're working on CentOS 7 support. That will go out with 2.0. Polish around some of the cookbooks. There's just a lot of, the cookbooks were written a couple of years back and haven't gotten huge updates and need to be updated for some of the new styles of cookbook authoring and just new init systems. There needs to be a little better systemd support in the cookbook. We don't have upgrade tooling. The new version basically has some schema changes. Have to do that. None of this stuff is huge. And then bug fixes. I'm really going to make a good effort to try to get as many of the bugs that we've filed against push fixed for this. Obviously, not every bug can get fixed, but if you have bugs, file them. I really want to know. So I'm going to talk a little bit about our roadmap. And there's a couple of caveats. Any roadmap, I've never worked at a company that the roadmap lasted past about 6 months. That 1 year roadmap horizon was always turned out to be fiction. So, this is like any other roadmap. This is what we want to deliver. And the nearer the thing is, the more likely it is to happen. The farther out stuff, well, take it with a little grain of salt. I just want to adjust expectations. So one thing is, 2.0 is our last big bang release of push. We've been, big bang releases. We had a big bang release of Chef 12, which a huge amount of stuff came out. We've kind of decided as a company that those don't really work that well. So we're a lot of efforts going into rolling releases out, lots of small RCs, just trying to get to the point where we build and deliver every day if we want to. So these features are going to be shipped early, shipped often. Hopefully I'll start having stuff rolling out for people to play with as far as release candidates for this very soon. Basically, there's just some stuff around our release system I need to sort out, and as soon as that's ready, there's also a few other barriers, but I really want to be trying to get this stuff out today. And I know one of our release people is here, and hopefully she's not going to kill me for saying that we want to do this all the time. But so platform support, right now, we're Ubuntu. We're CentOS 7's coming soon, Windows client only. AX and Solaris are on our list of things to tackle. The push client is so small, it should be pretty portable to anywhere. We've already ported to the Chef client. And if people have someplace they want to run push client on, I'm glad to take patches. Obviously, our official supported list is a bit more, that has to be somewhat controlled. But there's no real principle. Anything that looks like a Unix should be able to run the push client. ZeroMQ and libsodium are both extremely portable. And those are the only new dependencies beyond the existing Ruby dependency for push client. Key rotation support, basically, I want to add that as soon as possible because people are starting to use key rotation, and it's no good if you get blocked from using push because of that. Unfortunately, Chef server, when other things auth against Chef server for multi-key, the API assumes that there's only one key to auth against and doesn't handle that. So we need to fix that and fix push. One of the things I want to tackle very soon is access control. So push is an open source project. And one of the things I really want to do is to try to get community involvement. And so I've had a lot of requests for better ACL stuff. And so I'm going to be trying to get an RFC out very soon for people to kind of hash out what ACL shape looks good for push. Because there's a couple different conflicting, or at least not conflicting, but not overlapping requests. One is to control access on a node based on whether you have update ACL. So you can't run on a push job on a node unless you have the update ACL for the update access for that node. The other one is looking at persistent jobs, which is its own object that you have an ACL on. This is the other big one. So we want to integrate push into the Chef client package. We want to ship push with Chef client. The only reason we haven't done this until now is that push has been firing breaking changes at a much different rate than Chef client. I mean, Chef is, we just released 12. It's going to be a while till the next major breaking changes roll through. And that tempo isn't really well set up for the way we've been running stuff through push. I feel like we're really close to the last kind of chaotic set of breaking changes. And as soon as that goes out, which will probably be some very recent minor version after 2.0, I'm going to merge push into the Chef client package. So push will be available as an executable anywhere you have Chef client. This will be nicer for you because right now, push is a Ruby, 1,000 lines of Ruby, and then the omnibus distribution contains an entire stall of Ruby. So push client package is about 50, 30 megs. It's kind of hefty, and there's really not that much code. If you integrate it into Chef client, it'd probably add 2 megs to the size of Chef client and save you a step. As I say, the only reason not to do this is breaking changes right now have been arriving at a rate that isn't really congruent with the way we release Chef client. Chef client is much more stable. Great. So 2 more slides, and then I'll have questions. So scaling. I talked a little bit about the multiple command switch, and we're going to pick that up and look at some of that in 2.x later. The other thing is rate limiting. It's kind of natural to want to run a job with a large number of nodes. You just want it just makes sense to put an envelope or a limitation on how many nodes you can run simultaneously. So that's both a protection for the server and the push jobs. You can say if you typical Chef server that I see a lot of people run, if you run 1K nodes starting a Chef client run all at once, you're going to run out of depth solver workers or something else. And I'm allowed to say that I wrote depth solver, so it's my own burden to be blamed for. But that just is not a good procedure for people to use. This is more blue sky. This is the next protocol breaking change. I'm hoping to get to it later this year, but schedules vary. But one of the big things that people have talked about at push jobs is right now the server lives on the back-end node. So to connect to it, you need your nodes to be able to connect to the back-end. An awful lot of network configurations want to only connect to front-end nodes. Also, front-end nodes tend to be provisioned CPU heavily, while the back-end node is more of the I/O node. And so it makes a lot of sense to try to move push job server to the front-end node. Unfortunately, that's going to require a little work around making it a distributed application. And actually, the command switch changes play very nicely into that because there's some of the work needed to do there to build a directory service and stuff like that convey straight into this. So it's going to be moved to the front end. We expect it will improve scaling. Just having more cores, more CPUs to work on should help us a lot. And once we get the distributed stuff in the front end, we've actually done a lot of the work we need to do multi-master HA type behavior, which is right now, one limitation of push right now is if you fail over the HA node when it's running push, it essentially aborts the running job because we have to assume we've lost too much of the state to be able to follow the job flow anymore. So we're going to try to tackle the HA story a bit better there. And in general, scaling, our goal is to scale a Chef server. A few years back, we were excited. We announced we could run 10,000 nodes against a Chef server, or even 20,000 nodes. That's, I guess, pretty much old hat now. And we have people wanting to run hundreds of thousands of nodes against Chef server. And our goal here is to scale push along with Chef servers so that if you have a Chef server installation that's rated at a certain number of nodes, push should be able to manage it. So almost over, but we'll just briefly say another breaking protocol change, probably looking at leaving it 0MQ, all up in the air, playing with prototypes right now, but too early to say where we're going to head with that. But backwards compatible, we're not going to introduce a breaking change so that 2.0 clients and 3.0 client servers should play with each other well and vice versa. Final slide. This is an open source project. I'm trying to be super available to people. There are office hours. We have office hours for Chef in general, Monday and Wednesday at noon PST. I attended most of those. If I know someone's going to be there, I'm always going to make a special point of being there. So I'm both push questions and in general Chef server questions. I'm there for that. The master repository for push is Chef Push. File any issues, you hit here. I'll figure out where they belong. You can also file against the individual repositories. If you've already done the debug and you have an issue that you know where it goes, please file against there. Pull requests, always welcome. I'm working on making sure that we can run CI quickly and just get your pull requests through and integrated as quickly as possible. And running this is a very open project. Any new major features, I'm going to put an RFC out, and we're going to do it through the community process. So I really want people's feedback. I don't want, so much of this has been designed in a vacuum up to now, with talking to individual customers, but not really working with the community because it was a closed source private Chef feature for most of its life. But now it's an open source project, and I want it to be run that way. Anyhow, that's it for me. I don't know how much time I have for questions, but I will be in the chef booth after here for people to hammer me with questions or anything, show you my not so great demo again.
Is the stampede issue, is that related to basically the run list being evaluated for every single node, even with Chef Push?
Chef Push doesn't evaluate the run list. The stampede issue is simply kind of, a job is actually a synchronizing event in some ways. You know, you go to all this trouble of dithering and spreading your heartbeats out and otherwise things, and then you start a job. And that's like the firing gun, and the stampede starts. And so this rate limiting thing is to smooth out that starting process. That's why I want to build the rate limiting features, so that we soft start and sort of flow them through instead of trying to start all the nodes executing at once.
Are there like one or two top sort of real world use cases that you're taking into account around what types of commands you expect people to run most often?
Well, I mean, obviously Chef Client is one of them. There's a couple of, like, partial run lists, and Chef Client is one of the use cases. There's a model that I've seen a lot of people do where you deploy one node as a guinea pig, watch it for a little bit, deploy 10% of your nodes, watch them for a little bit, and do the whole shebang. And so partial run lists can be kind of a model for these kinds of sort of stick your toe in the water, test the temperature type deployment strategies. And so Push, we're very much thinking of that use case. We did consider rebooting as a use case. That's not yet quite there because there's some pull yourself up by your own bootstraps problems with rebooting. But system patches, definitely a lot of that kind of thing. Actually, the other thing we have people using it as is almost just a remote work server, where Push Jobs is being used to fire off units of work to a group of nodes. Which wasn't what we anticipated, but seems to work well, and we're going to try to look at that as a use case to support its own.
The whitelist at the client level, right?
Correct. The whitelist is at the client level.
Is there any work progress to push at the chef server level?
Not at this time. I'd be interested in, if you have a use case, I'm glad to talk about it.
We have a definite set of commands that we want to run across our infrastructure, but we don't want to lay down that file on each and each infrastructure where SS can go and hook around that.
So this is where this idea of having a predefined job as its own entity might help out. The idea is you define a job with a list of nodes, and then you attach users who can run that, and that would bypass the whitelist by design because it would have its own permission system, and so it would be a hard-coded job. How am I doing?
We're running over time at this point.
Okay, so I'd be glad to field questions maybe outside, or I need to turn the room over to the next lucky. So thank you very much.